Hello, everyone. My name is Pariya Sarin, and I'm an 18 years old college student in the Bay Area. And as program chair of Global South and AI, I would like to welcome you to our Global South and AI Affinity Group at NeuroAdvice Workshop. We have 8 brilliant speakers this year speaking about a range of topics within language AI, from diversity to environmental concerns. And today we are here with the amazing Elisa Torres Durney, who will be talking about the exciting field of quantum computing and her work to make quantum computing resources accessible for all, and building a quantum computing network globally, especially for underrepresented communities. She will shed light on the current state of quantum computing, its increasing visibility in media outlets, and highlight the need to address a critical aspect that has been overlooked, the future workforce. So, I'll give a short bio on Lisa, and she can go more into her bio. So she's a Chilean student and founder of the organization's Girls in Quantum. And with a full scholarship from IBM, she completed the 8-month Introduction to Quantum Computing program, where she realized the great potential of this emerging technology, but also the few women and girls who are involved. That's why at the end of the program, she founded her organization, Girls in Quantum, a nonprofit organization. They provide free educational resources for girls and students around the world so they can get involved in the field of quantum computing. They want to bring them the opportunities they need to collaborate and thus make an impact by strengthening their abilities and talents. They have already done more than 200 educational videos and posts about quantum computing, organized online seminars with international experts, conducted research and courses, impacted girls and students in more than 21 countries. She has also been invited to participate in international conferences organized by the Women Economic Forum, Uptown Basel, the Economics, IBM, and Quantum Latino. And so, thank you, Lisa, for joining us today for this workshop. And I can also go a little bit more into your bio as well. Anything you'd like?
Sure. No, thank you so much, Pariya, for this great introduction. I'm so honored to be here, telling you and telling everyone as well about what we do as well at Girls in Quantum, especially empowering, as the title says, the next generation of quantum leaders. So I'm really excited and looking forward to telling more. So as Pariya says, I founded this organization, which is Girls in Quantum, and we started promoting we started in April of 2022. So in that year, we started telling or sort of chatting with other classmates and students about our interest in quantum computing. And they were all really excited to tell more about this area and this emerging technology to other people around the world. So that's how we started. We started saying, okay, so how can we start telling something that could sound really difficult into something more interactive, even fun? So that's how we started. We developed some videos and we started with some conferences. And yeah, I think that, so what we do in sort of short terms would be democratize quantum computing education through the mentorships that we do, educational resources, and lastly, and I think that most importantly, the partnerships that we've been doing. So there's actually one really interesting about a book that I will tell you more deeply afterwards. That is really exciting as well, that I want to share with you. So we have 3 main pillars, and the 3 of them are inspire, connect, and collaborate. We know that it's really important to just not to go to schools and tell them like, hey, you need to be involved in quantum computing, rather than just telling or inspiring, going as a students, peer-to-peer, telling them about what can we do as a students, what can you do in the future as well in the area of quantum computing, and also sort of engaging with other peers. I think that's sometimes it could be a little bit discouraging when there's like only you learning a field that is new. So what we do at Girls in Quantum is connect them in a community that it's sort of encouraging and also supportive as well. And lastly, we collaborate. We love going to schools in different regions, and we have sort of different ambassadors that try to go to their organizations, local organizations that can support us and see other ways of like organizing events as well. So I think that this is like, I always mention it, like the $1 million question. When I'm mentioning about quantum computing, Girls in Quantum, everyone, like the first question that is on their minds is about what is quantum computing, right? So really try explaining quantum computing in different ways. So just to tell you in advance, I've been talking to some physicists and they tell me, hey, Elisa, I've been in the field for more than 25 years and I still don't understand it fully. So no worry if you don't understand it at the first time. So quantum computing could be defined, for example, as a new technology that is enhancing quantum computing or quantum mechanics to solve problems, certain problems that our computers cannot solve. Certain problems that could be more complex and that could be solved also more efficiently and faster through the quantum computers. So that's great. So I think that one of the first things also that we need to sort of understand is the difference between the classical computers and the quantum computers. So when I started learning quantum computing, I wondered or questioned to myself, do I know what are the classical computers? So I started sort of researching more and I found out, okay, so classical computers, the ones that we're using right now, for example, to listen to this talk or listen to this meeting, the ones that we communicate through our phones, for example, so or iPads, tablets, iPhones, or phones, all of those are through classical computers. So those works in a binary state, so they store a lot of information. I imagine that you have lots of emails, lots of messages as well, and all of that information is stored through the binary sort of method, or that is zeros and ones. So there's one or the other, zeros and ones, that is storage all the information that you have. But the quantum computers do not have like the 0 or 1, the binary state. They have the quantum states, which are like in the spectrum of 0 and 1. So it could be, for example, a superposition between one or the other. So it's not a defined state. And so what does that mean? That means that our quantum computers could be more faster and efficient in many different ways for certain problems. So that's great, because that's what we need in the future as well, to sort of solve different issues that we may have.
Yeah, and
so yeah.
Basically, since this is a Global South and AI workshop, we would love to talk a bit about Global South and AI and how quantum computing is tied to our mission of creating more inclusive language models. And so let's talk about the connection between generative AI and quantum computing, as this alliance could bring about more complex and efficient generative models, especially since as the more complex the Gen AI, the more resources it takes and the more cost. So how can LLMs help make quantum computing better and vice versa? So two of the main points here is efficiency and accuracy. So one point is it reduces the time it takes to train LLMs. And then QNLP is quantum natural language processing, which is the application of quantum computing to NLP. And this enhances NLP, so better sentiment analysis and language translation, for example. And this is where we can really see an impact, especially with our mission at Global South and AI and building more inclusive language models, because quantum computing can help build LLMs with a more nuanced understanding of language, which you see in many of our authors' work. So a question you may have is, why do we need quantum computers to help you better? Which is that, as Elisa mentioned, quantum computers take properties of quantum physics to store and process information, which means they can go through large amounts of data and calculations faster than on a classical computer. And then also quantum computing can help with fine-tuning more efficiently as well. So these are just some of the various ties between quantum computing and LLMs, and why we should use quantum computing to enrich generative AI. And Elisa can
Yeah, for sure. No, thank you so much for telling that, especially as that's the main topic of the conference. And I think that as students, we're really wondering, okay, so how could this be applied in different sort of scenarios or in different industries as well, and or areas in the case of AI. And so it's really interesting to get to know how these both sort of emerging technologies converge. And in the same sort of way, many students also wonder, okay, so how can we apply what we heard about quantum computing, what we have heard about quantum computing in our real life, right? So we've been gathering like different sort of resources with the Girls in Quantum team. and we have found these great sort of examples. So I'll mention one of them for you that you can also look forward to see in the future, in the near future. So one of them is right here, the one from Mercedes-Benz. So crafting the future of electric vehicles. So Mercedes-Benz has this goal of going carbon neutral to 2029, 2029. And how they are going to accomplish that. So they are partnering with IBM to sort of simulate different interactions between the molecules of the batteries with quantum computing or with quantum computers, so they can be more efficient and accelerate those processes. So that's a great thing, especially as Mercedes-Benz is not just working on efficiency process sort of problems or issues, but also in terms of sustainability. So how the company can evolve or can go and lead that direction of sustainability for their cars. So that's such a great example in terms of imagine how many years or how much time will it take for scientists to sort of simulate all the possible interactions of molecules in a battery or within a battery. So that's just so great to see how that's happening right now and how we can see that in the future as well. So I'm really looking forward to see that. There's also different examples. For example, ExxonMobil collaborated also with IBM in terms of accelerating the chipping of different sort of the demand and the tipping, the supply chain problem that we have. So how can they accelerate those processes, optimizing or the optimization of different routes, marine routes. So that's so great to see also in terms of this time-consuming task as well. So one of the things that also excites me is the quantum future. So what's happening next? So just to tell you more, a startup sort of did this new that right here is like the record-breaking quantum computer has more than 1,000 qubits. So that's great how it's evolving the field. So I think that some years ago there was like, for example, 100 qubits, and now we're evolving to 1,000 qubits. I think that although 1,000 qubits won't be able to change many problems, it will be still a great advance or a great milestone for the quantum computing world. Also, just to tell you small numbers, so the Pentagon seeks to invest $75 million for this new program of quantum technologies. However, that's the smallest one since the US as a whole is planning to invest $2 billion. So that's so great to see how this could evolve and also for more research and development as well. I think that one of the things that I've been also sort of been asked is why girls in quantum. So I will definitely try to go over this as well. So the terms of involving more girls, empowering more women in STEM is something that I really I really sort of work on I've been working throughout these years, especially as this sort of issue in terms of the gender gap is devastating for everyone in the field, for the talent, the diversity that it's needed. So that's why we try to approach 3 Girls in Quantum. I think that although it's not just for girls, but we do have this focus, we really want to sort of encourage more people in the field, especially women. So yeah, this is my wonderful team. And I'm working right now with some really great ambassadors and people all over the world. I'm so happy to work with them. So for example, I've been working with Sabina, with Gihad, with Maria, with Brini, and they're all from different countries, and they sort of incentivize this for the collaboration across our country and across the world as well of quantum computing. So we're really excited, and I'm so thankful for their support as well. I think one of the last things as well that I want to mention is the sort of the supporters that we have, the impact that we've done. So as you mentioned, Pariya, we've been reaching more than 2,000 students worldwide from all of these companies as well that have been supporting us to sort of create a program with them, a mentorship program to organize or go to and attend these conferences, and also to just go and visit students that perhaps have no idea about quantum computing, but they can learn through us. So that's so great. Some of our seminars have been really exciting. We have been, as you mentioned as well, sort of organizing different seminars for people to understand quantum computing, not just in one language, but also in different ones. So Spanish, there's also our ambassador of India told us like, well, what if we start translating some content to Tamil as well? So we started translating some content to Tamil. So there's lots of different opportunities that have been happening right now, and it's so great to see sort of the contribution of everyone in the team. So I'm really grateful for that. And well, here are some of our projects. As I mentioned before, we have organized different sort of interviews and seminars, but also this one that we have these quantum conversations with professionals and enthusiasts, so they can tell us about their background, what they have been doing, and how they sort of approach different challenges throughout their sort of work career. And also something that I want to share with you is the Kiskit Fall Fest that we organized recently. So this one was a really great hackathon, the largest one in Latin America as well, that we organized with Qiskit and IBM, and we gathered more than 2,000 students that learn about quantum computing, some of them for the first time. So we're so happy about the projects that we've been organizing, and we also want you to be involved. So if anyone is interested in learning more as well, we'd be happy for them to get in touch to learn more about what we do, and also if they want to contribute as well with their perspective or any sort of educational resources they have. So yeah, here are our sort of social media as well, LinkedIn and Instagram, so they can be in touch.
Thank you for your presentation, Elisa. I got our audience to learn more about your mission as CEO of Girls in Quantum. And now we'll just go into some questions. So one question that I'm sure a lot of us have is, how did you get started with IBM? Because it seems like that it was really impactful for you.
For sure. No, thank you so much for the invitation, first of all. And yeah, I think I will. With IBM, I got involved because it was during the pandemic that I was really having plenty of time, honestly. And I said to myself, well, why not exploring, getting to know other people as well in the online era, sort of. And I started joining different programs. I applied to them, and I received the good news of sort of being accepted for this online program of quantum computing through IBM. And that was so great. I think that's how I got involved with them, and it was so great to learn from the experience of different professors as well, and people that are working in IBM, to sort of who I can become in this sort of area.
Yeah, and for those of you who are joining us at New RPS and just want to know a little bit more about quantum computing, you also talked about qubits. Can you explain a little bit what is a quantum bit for those of you?
Yeah, for sure. So I think that the main thing that we need to understand is what is a bit, right? So the bits are the ones that function in the zeros and ones, so the binary states. That is like a really, we could say, easy way or to understand. So it's one state or the other. But the quantum bits have like three main principles as well. Or there's like three main principles in quantum mechanics. There's the superposition, interference, and entanglement. So they're really interesting. I really encourage you to sort of, if you are really interested, to go learn more from our website. So I don't know if you've heard about the Schrödinger cat. That's a really good example. Like there's like in the quantum bit, you have many probabilities, right? Or being within sort of the spectrum of 1 and zeros. So there's like within quantum mechanics, there's like superposition, and the Schrödinger cat is like the cat is within a box that is like totally sealed, so you cannot see anything. And in the box, there's like a cat and sort of a poison. So you don't know if the cat is dead or alive. So that's kind of the superposition, the quantum superposition that it is. So in your head, it's like the cat could be in this superposition of dead or alive, because you are not being able to see what is inside of the box, right? So that's kind of what superposition is. Just to explain one sort of example of the many properties, of the three properties. But it's really interesting. I really encourage you to learn more through our Girls in Quantum website. That's a really basic example. But I'm sure that it will be really interesting for you to sort of go and look for this quantum mechanics course that we have.
Yeah, that sounds good. And then you also provided the information here, so for everybody who wants this whole organization for that. And then you also touched upon the importance of increasing representation and resources for girls in quantum computing. I was wondering your like thoughts on how do you think girls in quantum will influence the workforce and the future of quantum computing?
For sure. So I think that right now, Girls in Quantum is really sort of encouraging in terms, as you mentioned, diversity and also more females in the field. I think that that's needed, and that's how we do it. So we do have sort of programs that are just for women or for females. So we can encourage them. We can go to their schools and tell them like, hey, you can also be involved. We've been having many challenges in terms of people or females or girls and women that have been reaching us, and they tell us that they have either there are sort of stereotypes for women being in STEM fields. There's also sometimes even political issues. So that's what we try to bridge in Girls in Quantum. I think that as students, of course, we cannot save the world, but we try to organize these programs that could have sort of this small impact in one person, in one girl, and that's what it's sort of encouraging for us as a team.
Yeah, absolutely. And then one big part of Girls in Quantum is, of course, the diversity and accessibility internationally, including global South countries. So, what are your next steps or the future of Girls in Quantum in terms of like expanding the organization more internationally?
Yeah, no, that's a great question. I think that, well, right now we're seeking for sort of funding opportunities and investment. So I know that right now we're a nonprofit organization and that we have been all working voluntarily. However, we know that it's not sustainable in the long term for everyone to work voluntarily, for sure, because we're just students, but we need also sort of other ways to get involved in the organization. So we want to apply for funds and seeking for other opportunities that could help us reach other countries and reach other schools without having this sort of financial burden or financial constraint as an organization or as a whole, or depending perhaps from other companies. So we hope to do that. And as well, if anyone's seeing us and has perhaps this willingness to help us, we'd be more than happy to get in touch.
Yes, and with that, we can maybe wrap it up with one last question, and then anything else Elisa would like to add. So I guess so. One last question we can ask is that, as the future of in the future of quantum computing, how do you think that, or what steps do you think that industry leaders, educators, and policymakers should make to ensure that the benefits of these technologies are accessible to everyone, regardless of their background, their identity?
Yeah, I think that's also a great question. Right now, the sort of the main concern in Girls in Quantum is how can we democratize the education within our peers or within our reach. So I think that one of the things that could be sort of encouraged by other people or perhaps by policymakers would be sort of showing or having this visibility of the organizations of what they are doing in the area, in the field. And yeah, I think that that's what it's really encouraging for me. And I hope that sort of different schools in whether it's here in Latin America or in other countries as well, they could start sort of showing, let's say, Girls in Quantum or other organizations right there, so we can start doing these alliances, partnerships, and this education could be free for other schools. I'm really looking forward to that future, to see other students learning quantum computing and also having these connections to other companies. I think sometimes we are just focused on learning quantum computing, but also what about the side of, okay, let's connect this company that is currently working with quantum computing with this sort of organization or with this school, so they can sort of bring other experts. So I'm really looking forward to that.
Yes, and thank you so much, Elisa. Thank you for all the work that you're doing, and I think this is very inspiring for our audience and whoever will, and NeurIPS, and so thank you all for joining us at our Global South and AI Affinity Group at NeurIPS workshop. And thank you, Elisa. Do you have anything to?
Yeah, no, for sure. I just wanted to thank you, Priya, for hosting this event or in my presentation as well. So I'm so happy as well for the invitation of IPS and Global Sci conference. So thank you for organizing this. And yeah, I'm really looking forward for any questions as well. If anyone is interested to reaching out to me personally, there's my LinkedIn right there as well. So yeah, thank you so much for the invitation.
Thank you.